Okay, so members, we are going to see more examples about permutations, but please, before we start, don't forget to subscribe to the channel. Now, in these examples, I need you to be more careful because they are a bit technical. Now, here, for example, we are going to see number one. What are they looking for? In how many ways can 5 men and 3 women be arranged in a row if no 2 women are standing next to each other? Now, here they are putting the condition on women. So the women should not be standing next to each other. Meaning, to avoid that, we should put a man in between. Now, I'm assuming if this is a woman and this is a woman, I should put a man in between so that I avoid them standing next to each other. Meaning that these men can be arranged in 5 factorial ways. So this one can be here, can be here, can be here. So for them, they are 5. They can be arranged first of all in 5 factorial ways. Times. Now after arranging them in those ways, now I have 1, 2, 3, 4, 5, 6 spaces where these women can fit. So the first one can take on all these 6 spaces. Times. If this one takes on one of the 6, means that they have been made in 5 spaces. So a second can take on those 5 spaces. If she takes on the 5 spaces, it means that there are 4 remaining. This now has a chance of taking any of those 4 spaces. So from there, we shall be having times, and the answer I have is 400 ways. So those are the ways. Now these women are different, of course. That's why I'm assuming they are different. I'm not dividing with anything. When you come to success, in how many ways can letters of the word success be arranged if no 2 S's are next to each other? Now I divide still. Because they are putting conditions on S, I divide. It means that S can be divided by U, C, and E. Now, it means first of all, these ones I can arrange them in 4 ways. So I can arrange these ones in 4 factorial ways, but because these 2 are similar, that's why I'm dividing it by factorial. Then times. Now the space after putting these ones in this order, it means that these S's can take on 1, 2, 3, 4, 5 spaces. So if one S takes, so can take on 1, 2, 3, 4, 5. So it can take any of the 5 times. If it covers that one, it means that the next S can take on 4. And if those 2 take on, out of the 5 they take 2, it means that the remaining will be 3 spaces. But because these S's are similar, that's for them also, they can be arranged in 3 factorial ways, because for them they are similar, which is going to give me, when you compute that, you have 4, 2 times. So here I have 120 ways. When I come to this one parallel, in how many ways can letters of the one parallel be arranged if B and R are together? Now, if B and R are together, this is how I write it. Now, in counting, I assume this is 1. So, I count now, this is 1. How many letters are there? So, when these ones are together, you count it as 1 letter. So, I have 1, 2, 3, 4, 5, 6, 7. So, I have 7 factorial over those repeating. So this one is repeating 2 times, then times, L's are repeating 3 times, then times. These 2 can be arranged in 2 factorial ways. I can put R first or P first. So they can be arranged in 2 factorial ways. And the answer here I will get is 7 times. So here you get 840 ways. When I come to this, now the women, here they are telling us in how many ways can 3 women and 4 men sit in a line if the women always sit together. Now, these 3 women I'm going to sit together always. Meaning, if they are together, now there I consider the 3 to be one person. So I count now 1, 2, 3, 4, 5. So I have 5 factorial then times, because these women can be arranged, this one can be here, this one can be here. So because there are 3, they can be arranged in 3 factorial ways. And these women, of course, they are different. So that's why I can divide. So there, you just press your calculator and you say 5 times the 3 factorial, and the answer is 720 ways. So remember, that's how we handle that one. Please don't forget to subscribe to this channel. I wish you the best.